Hello everyone, my name is AMMAJI DUPPADA. In this session today, we are going to see the method 7 called exact differential equation form. It means the differential equation form which is available in exact form like. So what is that form? The form is exactly looks like this. M into dx plus n into dy is equal to 0. It means the given differential equation is looking like this. Here m and n are functions of x and y. Means m also is a function of x and y, two variables. N is also a function of x and y, two variables. Let us say it may be e power xy, it may be log x plus y, it may be e power x into e power y, like that. So m and n are some function of x comma y. And if the given equation is in this form, you have to check whether it is exact differential equation form or not. So what is the necessary and sufficient condition to check whether it is exact or not is you have to calculate dou m over dou y, you have to calculate dou n over dou x. It means dou by dou y operator, you have to operate on m. Dou n by dou x operate, dou by dou x operator, you have to operate on n. So why dou came here? See, so far we deal with d terms only. Differentiation term nothing but d terms only, but here differentiation terms we are saying dou. Why? Because here variables are two. Here variables are two, because when m is function of two variables, you cannot say dm by dy. Why? Because m is not only depending on y, m is also depending on x. So you have to use partial differentiation. I told you, when the variables are more than two, are more than or equal to 2, you have to use dou only. So please make it clear this d and dou term. So if so, if necessary and sufficient condition is satisfied, so what is the solution? The solution is looks very simple, frankly. And here the solution is you have to apply integration on m into dx plus integration you have to apply on n into dy is equal to c. That's it, the solution. But here, in the case of first integral operator, you have to treat y is constant. Constant means you should think like it's a real constant. It means like you can feel y as k, or y as 10, y as 20. If that is the case, what we do while operating by in integrator, that the same thing we will do in the procedure also. So in the second term, n into dy, free from x terms, it means in the n, whatever the x term is there, that you have to remove. It means only y terms in the n you have to write here is equal to constant. After that, you will write, you will have some procedure to solve it. That's it. That is the final solution. Frankly, it is very simple. So only one thing you have to check is given differential equation is available in this form or not. If once the given differential equation is available in this form, you check dou m, you calculate dou m by dou y, you calculate dou n by dou x, you check whether both are equal or not. If both are equal, then solution is simple, because it will come under exact form. If it is non-exact, then that is the different case. Actually, we have to convert into exact, then we will apply solution. That is a different case that we will see later on. So straight away we will solve one problem. Okay, so the given example is looking like this. So it is looking like, of course, this whole thing I can treat as some m is function of x comma y. This whole function I can treat as n. This is also a function of x comma y. So see, now equation is looking like m into dx plus n into dy is equal to 0. Now, okay, it is looking like that exact differential equation form, but I am not saying that it is an exact. Now I have to check whether it is exact or not. Check whether it is exact or not. Checking I am doing. So to check that, what I have to do, first I have to calculate dou m by dou y. Dou m by dou y means what? Dou by dou y operator, I have to operate on m. What is m value here? Y square e to the power xy square plus 4x cubed. Calculate it. Dou by dou y. So when you are treating with dou by dou y, x should be constant. X should be constant. So it is looking like UV formula, y square into e power x, e power something, e power something is e power something only, e power xy square. But here remember, whatever thing you have treated as x, xy square you treated as x, right? Something, that something you have to differentiate again. When you do that something separately, if you differentiate with respect to y, you are differentiating, so x is constant here. Integration differentiation of y square is 2y. This is the term, plus e power xy square, e power xy square into differentiation of y square, how much? 2y. Differentiation of 4x cube, 4 anyhow constant, x is also you have to treat as constant when you are differentiating with respect to y, because you are doing partial differentiation. When you are doing partial differentiation with respect to y, x you should be treated as constant, you should treat it as constant. That's why I bring x here as a constant. Like, it means if in the place of x k is there, how you will do? Same manner you have to do in this case also. So differentiation of y 4x cube with respect to y is 0. So the final term 2xy in 2xy cube into exy square plus e power xy square into 2y. This is what actually dou m over dou y. Now calculate dou n over dou x. It means you operate dou by dou x on n. N means what? 2xy e power xy square minus 3y square. That's it. So with respect to x you are doing, so y is constant in this case. Okay, in this case differentiation you are doing with respect to x, so y is constant. So in the first term 2y I can take it out, because 2 constant, y constant. X and e power xy square terms are there. It is like uv formula only again. So x into e power xy square, e power xy square only, because e power something is e power something only, but something again you have to differentiate again. That something is what we called xy square. What is the differentiation of xy square? Y square is already constant, so differentiation of x is 1 plus, so e power xy what we do, x into e power xy square plus e power xy square into differentiation of x is 1. It means uv formula I have applied. Differentiation of 3y square is 0, because 3 is constant, y is also constant. See, remember in this, don't get confused. Here what already 2 comma y I have taken it as, I have taken it out because they are constants while doing with respect to x. And x into e power xy square, uv formula I have applied. X into e power xy square into y square plus e power xy square into dou by dou x of x is 1. So finally what you are getting here, first term is 2xy cube e power xy square. Second term is 2y into e power xy square. Check this term and this term. Are they equal or not? They are exactly equal. So dou m over dou y is equal to dou n over dou x. So my condition is satisfied. So it is in exact differential equation form, exact DE form. So if it is exact differential equation form, what is the solution? Now we will see the solution in the next page. Now the solution we will see in the next page. So solution, what is the solution? Integration of m of x comma y into dx plus integration of n of x comma y into dy is equal to some constant, because one constant we will put, because one arbitrary constant will come because of order 1. So here I told you why you have to treat as a constant while operating this integration. Here n term should not having any x term, okay, should be free from x terms. Okay, it is n should be free from x terms, free from x terms. So what is m and n? Let me write separately here so that you will understand. M terms are y square. Okay, I think we can cut it. Okay, I will write e power x y square plus 4x cube. This is m, right? N is 2xy into e to the power xy square minus 3y square. So integration of m dx, it means y square into e to the power xy square plus 4x cube into dx plus, remember you have to treat y as constant. Every time you have to write this so that you will remember, otherwise you will be landed with a wrong answer. So n term is 2xy into e power xy square. See, if you put x is equal to 0 here, this whole term becomes 0 because it should be free from x terms. So what is the term remains? Minus 3y square only. 0 minus 3y square into dy. Now you no need to write free from x terms here every time. Now this time, because there are no x terms here, is equal to some constant. So y is constant. So integration of y square into e power xy square. See, I told you y is constant means you have to really treat y as constant only. It means like 10, 20. So if y is constant, y square also constant. So if you operate integration on this term, so y square you have to bring it outside as a constant. So integration of e power something only, e power xy square only. Anyhow, this c, y square is constant here. So like k, when you do integration of e power kx by k you will do, right? So e power y square x by y square you have to do. It means one thing, very simple thing. You should keep in mind that when I say it is constant, you should treat it like as a constant. So integration of second term 4x cube. So this is what do you call y you have to treat as constant. Integration of 4x cube dx. So 4 constant, integration of x cube, x to the power 4 over 4 plus integration of minus 3y square. Anyhow, minus here it is there, minus 3 integration of y square, y cube by 3 is equal to constant. Y square will be cancelled each other. So final solution is e power xy square. 4 will be cancelled again. X to the power 4 minus y cube by 3 is equal to constant. One more equation, one more line also you can write. 3 you can take what we call LCM. So what in that case, 3 into e to the power xy square plus 3x to the power of 4 minus y cube is equal to 3c. 3c you can treat as some c dash. Again, same thing, you can down you can write e power xy square plus 3x to the power of 4 minus y cube is equal to c dash. I think something I have, yeah, right. E to the power xy square plus x to the power 4 minus y cube by 3. Actually 3 will be cancelled right here. 3 will be cancelled here. So this 3 will not be there. So this thing you no need to write. No LCM. So final answer is e to the power xy square plus x to the power 4 minus x cube is equal to c. That's it. This is called final solution. So this is the way you have to do the problem. Okay, this thing is useless. This thing is useless, so I'm doing this. Okay, you got it right, because I forgot to cancel 3 here. So 3 cancel, so minus y cube term only will remain. So this is called final solution. This is what we call exact differential equation form. Let us go back once again to see each page what we have written. So what is the method 7 exact differential equation form? If the equation is looking like this form, mdx plus ndy is equal to 0, you have to check whether it is exact differential equation or not. If it is exact, the solution is simple. To check the condition, dou m by dou y, dou n by dou x, both you have to calculate. If they are equal, you have to apply this formula to find direct solution. It is direct method, you can say. So, but while operating with integral operators, you have to, two things you have to keep in mind, that in the first time, when you are doing integration of m into dx, y should be treated as constant, like y is equal to k. In the second term, when you do, you have to, it should be free from x terms. It means n function should be free from x terms. It means you can keep x is equal to 0. All the terms you can remove. So one direct example we have taken. So m, n, what are the m value, n value we know. Dou m by dou y I calculated, dou n by dou x I calculated, both are equal. So it is an exact differential equation form. So once if it is an exact differential equation form, the solution is integration of m dx plus integration of n dy is equal to c. So here m y constant, free from x terms. Simple. You can apply integral formulas that I told you to remember all the time. All the basic formula you have to remember. So finally you will get a solution. So that's it. Thank you all for watching this video.